You have seen an apple fall from a tree 1,000 times. It seems so simple. The earth pulls it down, right? That is what we have believed for centuries. But Isaac Newton was wrong. There is no invisible rope. There is no force pulling that apple. In fact, you are being deceived by your own senses right now. The truth is far stranger. It involves the fabric of the universe itself, curving and twisting in a beautiful dance. Once you see it, you will never look at a falling object the same way again. It starts with a feeling. You stand on the ground and you feel heavy. You jump up and something drags you back down. It feels exactly like a rubber band attached to your belt, pulling you to the floor. It feels like a force. And Isaac Newton, he was a genius, perhaps the smartest man who ever lived. He took that feeling and he turned it into a law. He gave us equations that are so precise, so incredibly accurate, that we still use them today. If you want to build a bridge that doesn't collapse, you use Newton. If you want to fire a cannonball and know exactly where it will land, you use Newton. If you want to send a robot to Mars to drive around in the dust, you use Newton's math. It works. It works beautifully. It works so well that nobody questioned it for 200 years. That's all you need, right? But there is a problem. A nagging problem that actually kept Newton awake at night. He knew how gravity behaved. He could calculate it. But he had absolutely no idea what it was. Look at the moon. It is orbiting the Earth. Newton said the Earth attracts the moon. But how? There is nothing between them. No ropes, no chains, no gears, just empty, silent space. How does the Earth reach out across 240,000 miles of absolute nothingness and grab the moon? Does it whisper to it? Does it send a messenger? Newton called this action at a distance, and he hated it. It seemed like magic. It seemed like sorcery. How can an object here affect an object way over there instantly without touching it? Imagine two magnets on a table. You push one, and the other moves. It feels like magic invisible springs. But we know now that there is a magnetic field there. And with gravity, Newton didn't have a mechanism. He just had a rule. So he compromised. He essentially said, I do not know why it happens. I just know that it acts as if there is a force. And because the math worked, we all accepted the invisible rope. We accepted that objects just naturally pull on each other. But nature doesn't use invisible ropes. Nature doesn't do magic. The universe does not have a mechanism for reaching out and pulling. The reason the moon stays there, and the reason you fall down, is not because of a force pulling you. It is because the stage you are standing on is playing a trick on you. So here is the new picture. Forget the ropes. Forget the invisible chains. Imagine the entire universe is filled with a sort of fabric, a vast, invisible sheet. Einstein called it Spacetime. But don't let the fancy name scare you. Just think of it like a giant, stretchy trampoline or a tightly pulled rubber sheet. If there is nothing on the sheet, it is perfectly flat. If you roll a little marble across it, what happens? It goes in a straight line. It goes on, perfectly straight, until it hits the edge. Simple. But now, take a heavy object, a bowling ball, and place it right in the middle of that sheet. That is our sun. What happens to the fabric? It sags. It stretches down under the weight. It creates a deep valley, a dip in the geometry. Now, take that marble again. That is the Earth, and roll it past the bowling ball. And what does it do? It doesn't go straight anymore. It curves. It starts to circle around the bowling ball. It creates an orbit. Now, look closely. This is the moment everything changes. This is the secret. Does the bowling ball reach out and grab the marble? No. Is there a magnet inside pulling it? No. The bowling ball is just sitting there. It isn't doing anything to the marble directly. It isn't even touching it. The bowling ball has simply changed the shape of the mat, and the marble is just following the curve of that mat. The marble thinks it is going straight. It is trying its best to go in a straight line. But a straight line on a curved surface ends up being a circle. It is just riding the dip. It is falling around the curve. This is what gravity is. It is not a force. It is a shape. And the Earth sits in space and bends the geometry around it. It creates a hill in the nothingness. When the moon moves, it is just trying to go straight, but it gets caught in the valley that the Earth created. It rolls around and around the rim of that valley. It is effortless. It is lazy. It is just following the path of least resistance. So when you see an apple fall, the Earth isn't pulling it. The Earth has curved the space around the apple so intensely that staying where it is becomes impossible. The space itself is tilted downward. The apple is just sliding down the hill of space that the Earth created. It is surrendering to the geometry. But I know exactly what you are thinking right now. You're sitting there or standing there, and you're thinking, this sounds nice. It sounds poetic, but it feels wrong. Because you can feel it. You can feel your weight pressing into the chair. You can feel the heaviness in your legs. If gravity isn't pulling you down, why are you stuck to the floor? Why don't you just float away? This is where your intuition betrays you. This is where the illusion is strongest. Imagine for a moment that we take you and put you inside a sealed room, like an elevator, out in the deepest, darkest part of space, far away from the Earth, far away from the sun, and nothing is around. You would float. You would be weightless. There is no up, no down. You are just drifting. Now, and imagine I attach a giant rocket engine to the bottom of that elevator and I hit the button. The engine roars to life and the elevator shoots upward. It accelerates. What happens inside? The floor rushes up and smacks into your feet. You get pushed down. You feel heavy. If you drop a pen, the floor rushes up to meet it, so it looks like the pen is falling. If you didn't know about the rocket, you would swear you were back on Earth. You would swear gravity was pulling you down. But there is no gravity. There is only the floor pushing you up. Einstein realized something that shattered reality. There is no difference. The reason you feel heavy right now is not because the Earth is pulling you down. It is because the Earth is pushing you up. The ground is literally rushing into your feet every single second and preventing you from following your natural path. In Einstein's universe, the natural state of everything is to fall. When you jump off a diving board, for those 2 seconds before you hit the water, you feel weightless. You feel light. We usually think that is the temporary state, but Einstein says no. That is the natural state. That is you following the curve of space-time perfectly. You are relaxing into the geometry of the universe. The violence happens when you land. The moment you hit the ground, the Earth gets in the way. It interrupts your path. It slams into you and stops you from following the curve. So, you are not sitting still in a chair. You are in a rocket ship that never stops accelerating. The Earth's surface is constantly, relentlessly pushing you upwards, accelerating you away from the natural curve you want to follow. And you are being bullied by the ground. That pressure you feel on your backside, that isn't gravity pulling you. That is the Earth shoving you, forcing you to deviate from the easy, curved path that nature intended you to take. But wait, I know what you're asking. If the floor is constantly accelerating upwards, does that mean the Earth is blowing up like a balloon? Is the planet getting bigger every second? That is the obvious question, isn't it? If I tell you the ground is rushing up to meet your feet, logic suggests that eventually the Earth should touch the moon. No, the Earth stays exactly the same size. It isn't expanding. And this is where it gets a little tricky. So watch closely. We have to stop thinking in 3 dimensions And remember that you are moving through time too. Imagine two ants walking on a giant orange. They start at the middle, walking north, side by side, perfectly parallel. They think they are walking in straight lines. But as they keep walking, what happens? They start to get closer together. Eventually, at the top of the orange, they bump into each other. Did they steer towards each other? No. Did a magnet pull them together? No. The surface they were walking on was curved. The geometry forced them together. Now, apply that to us. Space around the Earth is curved, just like that orange. The straight lines, the natural paths, all point inward, towards the center of the Earth. Space itself is effectively pinching inwards. Every object, every atom in your body wants to follow those converging lines to the center. That is the natural flow. But here is the catch. The Earth is solid. It is a rock. It is stubborn. It refuses to squeeze. The Earth is in the way. So, you have a conflict. The geometry of the universe is saying, go to the center, follow the curve. But the solid rock of the crust is saying, no, and I'm staying right here. Because the Earth is solid and refuses to collapse along those lines, its surface has to constantly push outwards just to stay in the same place relative to the curving space. It is not expanding in size. It is holding its ground against a collapsing geometry. Think of it like walking up a down escalator. You are moving your legs. You are pushing up. You're expending energy. But you are staying at the same height. You aren't getting bigger. You aren't going anywhere. But you are definitely accelerating just to stay still. That is your life on Earth. You're caught in a traffic jam between the universe trying to slide you into the center and the stubborn ground refusing to move. That constant, unyielding resistance. That is what you call gravity. We've all seen the videos. The astronauts on the space station, floating around, flipping in midair, catching drops of water. It looks peaceful. It looks like they have escaped the Earth. We even call it zero gravity. But that name is a lie. It is a complete illusion. If you built a tower up to the height of the space station, about 250 miles up, and you climbed to the top, do you know what would happen? You wouldn't float. You wouldn't drift away. You would be heavy. You would weigh almost exactly what you weigh right now. The Earth's grip is still tight. It is still pulling at 90% of its full strength. So, if the gravity is still there, screaming at them to come down, why don't they fall? Here is the secret. They are falling. They are falling right now. The space station, the satellites, and the astronauts, they are all plummeting towards the Earth in a terrified freefall. To understand this, you have to go back to a thought experiment Newton had 300 years ago. Imagine you have a giant cannon on top of a very high mountain, higher than the atmosphere. You fire a cannonball. It goes straight for a bit, then gravity pulls it down, and it hits the ground a few miles away. Now, put more powder in. Fire it faster. It flies further. The curve is flatter, but eventually, gravity wins, and it crashes into the ocean. But what if you fire it with so much power, with such incredible speed, 17,000 miles an hour, that as it falls towards the Earth curves away underneath it? Think about that. The cannonball is falling. It is dropping towards the center of the planet. But because it is moving sideways so fast, and every time it falls a foot, the round Earth curves away by a foot. It is falling, but it keeps missing. It is in an eternal fall, tripping over the horizon forever, never landing. That is what the astronauts are doing. They haven't escaped gravity. They have just surrendered to it completely. They are inside a cannonball that never hits the ground. They feel weightless, not because there is no gravity, but because the floor of their ship is falling exactly as fast as they are. No push, no resistance. Just the pure, terrifying beauty of a fall that never ends. But you might still be skeptical. You might say, okay, apples have mass, humans have mass. Maybe this curved space idea is just a fancy mathematical trick to calculate weight. That is a fair point. But Einstein knew that if he was right, there had to be a test that Newton could not pass. He had to find something that had absolutely no mass at all. Light. According to Isaac Newton, gravity is a force that pulls on mass. The more mass you have, the harder it pulls. But light has zero mass. It weighs nothing. Therefore, Newton's gravity should not be able to touch it. A beam of light passing by the sun should go in a perfectly straight line, ignoring the massive star completely. But Einstein said no. He said, space itself is the road. If the road is curved, the car has to turn. It doesn't matter if the car is a heavy truck or a beam of light. If the space curves, the light must curve. In 1919, the scientific world held its breath. A total solar eclipse was coming. An English astronomer named Arthur Eddington traveled to the coast of Africa to take a picture that would decide the fate of our understanding of the universe. The plan was dangerous and difficult. They had to wait for the moon to block the sun completely, turning day into night for just a few minutes. This would allow the stars to pop out in the darkness right next to the sun. If Newton was right, the stars would be exactly where they always are. But if Einstein was right, the massive gravity of the sun would act like a giant glass lens, and it would bend the fabric of space so much that the light from those distant stars would have to curve around it to get to us. This would make the stars appear to be in a slightly different spot, shifted to the side. The moment came. The sky went black. The birds stopped singing. Eddington took his photos, and when they measured the glass plates later, the impossible had happened. The stars had moved. They were not where they were supposed to be. The light had traveled billions of miles in a straight line, but just as it passed our sun, it rolled through the valley of curved space and bent. It was undeniable proof. Gravity isn't a ghostly hand grabbing heavy objects. It is the texture of reality itself, bending everything that moves through it, from a falling apple to a beam of pure, weightless light. But we are not done. We have to go deeper, because there is a flaw in what I just told you. You see, the bending of space explains why light curves. Light is fast. It screams across the universe at 670 million miles per hour. But an apple hanging on a tree is motionless. Even when it falls, it is moving incredibly slowly compared to light. The tiny curvature of space alone isn't nearly strong enough to slam it into the ground. So, why does it fall? This is the part that Einstein realized, and it is the most mind-bending part of all. Gravity doesn't just bend space, it bends time. And for slow-moving things like us, like rocks, like apples, the bending of time is the key. Here is the reality. Time does not flow at the same speed everywhere. Einstein proved that the closer you are to a massive object, the slower time moves. It is a tiny, tiny difference, but it is real. Right now, as you stand there, gravity is pulling on time itself. Time is actually passing just a fraction of a nanosecond slower for your feet than it is for your head. Your feet are effectively living in the past compared to your brain. Your shoes are aging slower than your hat. It sounds like science fiction, but we have measured it with atomic clocks. It is a fact. Now, why does this make things fall? Imagine an object moving through the universe. Even if it is standing still in space, it is hurtling through time. We are all traveling into the future every single second. Think of the apple like a car driving down a highway. This highway is time. The left wheels of the car are high up, away from the earth, where time moves fast. The right wheels are down low, near the ground, where time moves slow. What happens when you drive a car where one side is moving faster than the other? You turn. The car swerves toward the slow side. That is exactly what falling is. The apple is trying to move straight through time, but the slow time, near the ground, acts like a drag. It rotates the apple's path. It tilts the apple's movement through time and turns it into movement through space. The apple isn't being pulled by a force. It is simply steering towards the place where time is slower. It is trying to maximize its own aging, trying to find the path where time flows the most comfortably. We are all just surfing on waves of uneven time, sliding towards the slow patches. That plunge towards the grass is just the universe trying to balance its own clock. So, look around you. Look at the chair you are sitting on. Look at the screen you are watching. Look at your own hand. Everything feels solid. Everything feels grounded. But that is just a feeling. The reality is that we are all dancing to a silent tune played by the universe itself. You are not just a collection of atoms standing on a rock. You are a piece of the cosmos, caught in a grand geometric symphony. When you drop a pen, it isn't just falling. It is exploring the shape of space. When you stand up, you aren't just fighting weight. You are pushing against the curvature of time. We are, in a very real sense, made of the same stuff as the stars, obeying the same invisible topography that guides the galaxies. And this brings us to the deepest question of all. Where does all this mass come from? Why do we bend space in the first place? And some people talk about the Higgs boson, the God particle giving things mass. And that is part of the story. But mass is really just energy that is trapped. It is energy that is confined in a small space, jiggling around, desperate to get out. That energy, the energy of your atoms, the energy of the earth, dents the fabric of reality. It tells space how to curve, and space tells matter how to move. It is a perfect, unbroken loop. We don't live on the earth. We are woven into the same fabric as the earth. We are not separate from the universe, observing it from the outside. We are the universe, experiencing its own geometry. Every time you feel the heaviness of your body, you are feeling the universe hugging you, bending around you, keeping you here. It isn't a force pulling you down. It is the shape of home. So, we have peeled back the layers. We started with a simple question about a falling apple, and we found a universe made of curved paths, warping time and invisible geometry. We have learned that gravity is not a muscle pulling things together. It is the stage itself, bending beneath the actors. It feels like we have arrived. It feels like the final answer. But nature is never that kind to us. Just when we think we have unlocked the door, we find another lock behind it. And this one is jammed. Because here is the secret that physicists don't like to talk about at parties. We have two rulebooks for the universe. One is Einstein's general relativity, the rulebook for the big, the heavy, the smooth curves of stars and galaxies. The other is quantum mechanics, the rulebook for the tiny, the frantic, and the jittery world of atoms and particles. And the terrible truth is, these two rulebooks hate each other. Einstein's universe is like a smooth silk sheet. It flows. It bends gracefully. But the quantum world is pixelated. It is chunky. It snaps and jumps. When we try to combine them, when we try to calculate the gravity of a single electron, or what happens at the center of a black hole where a massive star gets crushed into a tiny dot, the math explodes. It gives us nonsense. It gives us infinities. This is the greatest embarrassment in modern science. We know gravity is geometry, but we don't know how to build that geometry out of atoms. Is the fabric of space smooth forever? Or is it made of pixels too small to see? Is space-time itself stitched together from something deeper, something more fundamental? Now, we solved the mystery of Newton's force by replacing it with Einstein's space. But that victory came with a cost. It brought us to the edge of a cliff where our understanding stops. We are still children playing with pebbles on the shore of a vast ocean of ignorance. We know that matter tells space how to curve. We know that space tells matter how to move. But that just pushes the ultimate question one step further back into the dark. If curved space creates gravity, what creates space? I'll leave you something to imagine.